Looking at exploring solids. So let's make sure we write all this down so you understand what's happening. All right. We are looking at a polyhedron is a solid that is bounded by polygons that enclose a single region of space. The polygons that a polyhedron is bounded by are called faces. So if we were to look right here, where's a good one? Okay, let's look at right here my paperclip holder. This is a polyhedron. We've got polygons on all sides, top and bottom, surrounding its space. These are the faces. Faces are like the rectangles right here. Okay? Edges is where two faces meet, that line where they both meet. A vertex is where three or more edges meet. It's like the corners or the points. And a polyhedron is regular if all its faces are congruent regular polygons. So here's a polyhedron where all of these triangles right here are exactly the same. So that is a regular polyhedron. Okay. Now we're going to talk about Euler or Euler's theorem, depending on who's pronouncing it. The number of faces, vertices, and edges of a polyhedron are related by the formula faces plus vertices equals edges plus 2. And we're going to determine whether each solid is a polyhedron and explain our reasoning. So, is this cone a polyhedron, yes or no?
No.
Why?
Because it doesn't have four sides.
Well, four sides doesn't matter.
Oh, I thought it
What's wrong with a cone? Let's think about what's the definition of a polyhedron. It's a solid that is bounded by polygons that enclose a single region of
There's
space.
no polygon.
Right, a circle is not a polygon. Okay. Is this shape a polyhedron? Yes. Okay. All sides are squares, which are polyhedrons, which are polygons. Okay, is this shape right here a polyhedron? No. Again, a circle is not a polygon. Okay, it's a cylinder with a circle at the top and the bottom, so it is not a polyhedron. Okay, what about this shape? Yes. Okay, all sides are triangles. Or square, which are all polygons.
would that be called the base then?
Mm-hmm. The square is the base. Okay, any questions about the definition of a polyhedron? Okay, let's go ahead and turn the page. Now we are going to count the number of faces, vertices, and edges of each of these polyhedrons. Okay, so I'm going to put F for faces, V for vertices, E for edges. Okay, so let's look at this first one. How many faces does this shape have? Now, there's a face in the bottom, that's the square.
5.
And then there's 4 triangles, so there's 5 faces. How many vertices does it have?
5.
Let's have 5 vertices. Okay, this is the one that's a little bit tougher. How many edges does it have? count those edges again.
12.
So we've got 4 on the bottom. 1, 2, 3, 4. And then 4 coming up. 1, 2, 3, 4. So a total of 8 edges. Okay. All right. We're looking at this prism. How many faces does it have? How many faces, guys? 6. 1 on the bottom, 1 on the top, and then 4 around the outside, so a total of 6. How many vertices do I have?
8.
A little bit more.
6.
No, wait, I'm sorry. Vertices and edges I got just mixed up. We have 8 vertices, we were right. Sorry. That was good. How many edges do we have?
12.
12.
Okay, let's count them.
4 on the top, 4 on the bottom, 4 going up and down to connect them. Okay.
5.
All right. How many faces does this prism have?
4.
So remember we have the top and bottom, that's 2. And then around the outside is 3. So that's a total of 5. How many vertices do I have? Good. How many edges do I have? So I have 3 around the triangle,
8.
3 around the other triangle, so that's 6, 7, 8, 9.
Well, let's count them. Ooh, this thing's
Yikes. Like,
You said yeah,
Okay, we're looking at this pyramid. Okay. How many faces do I have?
7.
So let's look at the bottom. How many sides is this bottom? Is this a hexagon, a pentagon? What shape is this? I would say it's a hexagon, right? 1, 2, 3, 4, 5, 6. So I have my bottom base, that's 1 face, and then I have 6 triangles, so I have a total of 7 faces. Vertices,
7.
7. Edges.
12.
So I have 6. Hold on, I didn't say it wrong. I have 6 around the bottom, and then 6 coming up, so it is 12. Just explaining how you got it. That's all.
I'll just use a calculator.
Okay.
Darn.
Let's do the theorem. We've got faces plus edges equals vertices plus 2. Faces, oops, excuse me, that's wrong. Don't know what I'm talking about. Faces plus vertices equals edges plus 2. There we go. That is the correct formula. Okay, now we're going to calculate the number of vertices of the solid, given that it has 10 faces, all triangles. Now it's really hard to draw that, but I could draw like a top view, like you would just see half of it. So I know I need faces, I'm looking for vertices, so I need to find edges. So I have 10 faces, I need to know how many edges I have in order to use this equation to find vertices. So I'm looking at triangles. So let's start with just doing 5 triangles. Okay? Here's 5 triangles and there's 5 underneath it. Like, let's say we're looking at one side. So I have 1, 2, 3, 4, 5 edges where the triangles are touching each other on the sides. So I know there's how many for the other side. If there's 5 meeting on the other side like a ball, there's 5 more, right? So 5 and 5. And then I have the 2 sides touching each other. 1, 2, 3, 4, 5. So I have a total of how many edges? 15. Okay, so I'm going to do faces, 10, plus vertices, I don't know, equals edges plus 2. Oops, edges is 15. 10 plus b equals 17. Now I'm going to subtract 10 from each side, and I get vertices equals 7. Okay. All right, I think the other one is a little bit easier to draw and to envision. Calculate the number of vertices of the solid given that it has 7 faces. So we know how many faces already. We got to find the edges, and we're looking for the vertices. 2 are pentagons and 5 are rectangles. So I've got this pentagon, and I have another pentagon, and they meet with these rectangles. Okay, how many edges do I have? 5 on the top and 5 on the bottom, right? And then 5 for them meeting each other. So a total of 15. So I'm going to say my faces plus my vertices equals my edges plus 2. So 7 plus vertices equals 17. So vertices equals 10. Okay. Let's turn this over. All right, we're going to name what each of these solids are. That is our next step, is to name each of the solids. Now, these are in net form. And you can't name them like Bob or Cindy, okay? They have to be like the name of their shape, right? So, the first thing we should determine is if they're a pyramid or a prism.
First one's a cylinder.
So,
It's a triangle.
this one's a triangle. Now, remember, it's a net, so it's like I took it apart. Like I cut it apart at its seams and folded it all down.
Is it like
So if I was going to fold it all up into a 3D shape, would this be a prism or a pyramid?
A pyramid.
Pyramid. Now, what is the base of that pyramid?
Triangle.
So we call it a triangular based pyramid. Okay. Now the next one, is it going to be a prism or a pyramid? Prism. And are all of the faces the same? So what are the faces? They're what shape?
Square.
So this is going to be a what?
a cube?
Cube. You could say a square prism, but that's the same thing. I don't know. It's less words if we just write cube.
It's a rectangle.
Okay. The next one, is it going to be a prism or a pyramid?
Prism.
A prism. And what is the base of that prism?
A rectangle.
Rectangular. A rectangular prism. Okay, next one, is it going to be a prism or a pyramid?
Pyramid.
Okay, and what's the base?
Square.
Square base pyramid. Okay, what's the next shape? Prism or pyramid? Prism is correct. It's not going to come to a point at the top. And my two bases that match are triangles. Those are my bases. So it's a triangular prism. Mr. Van Horst, am I spelling something? Am I spelling them correctly? Okay.
It's
All right.
It's a cylinder.
It is a cylinder.
Imagine those circles at the top.
Yeah. Cylinder, ER or AR? What shape is this?
On the baseball field, I don't know.
So think of it as this is going to wrap around here. These two sides are going to touch. It's going to be a
Oh, yeah, this one is a cone. Triangular cone.
cones always have a base of a circle, so it's always
Yeah.
just a cone.
Oh, good. What's this one?
Okay, is this going to be a pyramid or a prism?
Pyramid.
Pyramid, because this is going to be a top, like a
So it's
point
like
at the
a-
top, right?
Hectagon.
Hexagonal prism, yeah.
Yeah, I would call it a hexagonal with
Hexagon-based pyramid.
They put a
Hexagonal.
circle.
Oh, this is gonna be a star.
It's a star.
Now, if I put all the points up at the top, is it going to be a pyramid or a prism?
Pyramid.
Pyramid, and what's the bottom?
Hexagon.
Pentagon-based prism. Pentagon-based pyramid.
Base.
You're going.
This is gonna be a triangular pyramid.
It is. It's going to be but it's a different shaped triangle. This was an equilateral triangle. This looks like an isosceles triangle. If we wanted to be really specific, we could write that, but I think we're okay. Triangular based. Okay, this is going to be a prism.
Rectangular
And
prism.
I know these look like squares, but if we said a square-based prism, we think of a cube. So we're going to have to call this a rectangular prism. Okay, what's this one?
Ooh, a rectangular
Just a pyramid.
pyramid?
Rectangular base pyramid.
That's a pyramid.
Yep, because all this comes to a point.
Oh, I was thinking of like one of those prisms,
Yes.
like the one from Pentagon.
You got yourself on right.
This is
Rectangular
a cone.
based pyramid.
Cone is a weird way
This is a cone.
to see it.
And what is this? Pyramid or prism?
It's a
Prism. And what's the base?
Hexagon.
Pentagonal prism. Okay, let's turn it over. Okay, these last ones, we're going to have to make a net. A net is when you lay it flat out of this 3D shape.
Oh, I can't.
Okay, so let's start with a cone. We want like a circle. And we're going to draw on the diameters for.
Use that.
And we have
Choose like
the cone,
bush.
where this is 8.2.
you have to be an artist to do this.
No, I am definitely not an artist. Okay, now here is a prism. So we're going to draw that big square, and then the skinnier rectangle, and then a big square, and then a skinny rectangle, and then a rectangle over here, and a rectangle over here. And we're going to call this is 16 by 6 by 19.
You could draw a different. Like you could just have all the rectangles in one
Oh, I
line.
did that.
These always have to, there always has to be two that are not, or else it won't work, right? Because you have to have a top and bottom.
But if they're all in one line, you put them together, they all just loop around like that.
Right, they loop around like that, but you still have the top and bottom missing, right? So if I lined all these up in a row, unfolded this whole thing, actually. So if I had a Kleenex box that I unfold, okay,
No, it's just
so if I do what you said, have them all in a row, didn't have anything up here or down here, when I folded it back up, it wouldn't have a top or bottom.
Thank you for showing me the way.
That magical unfolding. Okay,
You're gonna be lost.
alright. Now we're gonna sketch the 3D version of the net. So let's make the pentagon. And I would draw in your stuff for the pentagon first. We've got our apothem. We've got our side length. And then we're going to take all of the vertices and draw them to one point. That's going to give me a lovely pyramid. And show that the length of this side, the slant height, is 20.4. And if I'm going to do it for a cone, we know the slant height is 22.4. I draw a circle at the bottom, and then I draw a dotted circle to show it's behind. It is a diameter of 20. Does this make sense?
Yes.
Okay, so you are going to now do your homework for the rest of the hour.